for the video. So if there's anybody who does not want to be recorded, leave now. But the recording should be going at this point. And I'm going to share my presentation here. I think that's the right window. Okay, does everybody see my slide?
We can.
Okay, so Dan had asked me to do a presentation on DMR for the Salt Lake County ARES next month on the 15th of July. And I said, that'd be great, but I don't know anything about DMR. So I spent the last week and a half or so learning about DMR and trying to understand enough about it to be able to do a reasonable presentation. So you guys are my guinea pigs. I expect to hear from you guys what you like and don't like about this presentation. And I'm actually going to turn my video off so I can get that out of the way.
And if we can have everybody mute their microphones, and unless they have a question, then of course unmute them.
Okay, let's see if I can start. I can see where the controls are here. We'll start the show. Okay, so can everyone see the slide? Okay.
I don't see it. I don't know what I done.
You're not seeing it, Dave?
This is Neil. Yeah,
Neil.
I don't know why. Oh, okay, I got it.
You got it?
Yeah, thanks.
Okay, so what is digital radio? Basically, you have your audio and data encoded digitally and sent out over the air. Their audio is encoded using a piece of software called a codec, which stands for coder decoder, and that is used to convert the analog audio signal into and out of digital, a digital signal. The data can be sent and received directly because it's already digital. Here's a kind of a block diagram of how the radio would work. So you've got your analog audio signal coming in here, goes into this AD, which is analog to digital encoder, which turns it into a digital signal. And that goes into this vocoder section, which is the thing that is the codec. That's what takes the signal and compresses it and does some manipulations on it. And that's passed off to this component of the radio. Meanwhile, data can be coming in through another mechanism and also is handed into this burst building stage. And what happens here is these two signals are combined and then converted into a single digital signal, which is sent through a digital transmitter and out through your antenna. Receiving works kind of in the reverse fashion. So there's several different implementations of digital radio. There's System Fusion, which is Yaesu's solution for digital radio. There's D-Star, which I'm not sure who created D-Star, but D-Star is a pretty widely used setup. It's available on a lot of different manufacturers' radios. I know, Neil, I know your Kenwood D74 will do D-Star, and I know a lot of ICOM radios will do D-Star. But today we're going to be talking about DMR, which is yet another implementation of digital radio. These implementations are not compatible with each other. So if you want to play digital radio, you have to pick one or buy 3 radios. So generally, a System Fusion radio will not do D-Star or DMR. A DMR radio will not do D-Star or System Fusion, and vice versa. So that's a sad fact about how things are, but I guess that's just how it is. So let's talk a little bit about digital versus analog. Why do we want digital versus analog? So let's talk about how we take an analog signal and we put that into the radio. So here's our analog signal that's coming in here, and this is frequency modulation, right? So we're actually adjusting the frequency of our wave to carry this extra information that's being given to us, right? So with digital, what we do is we take that signal and we kind of quantize it. So we identify where this kind of fits into this block grid here. And that turns into a bunch of numbers, right? So here's 0, this is 4, this is 5, back to 4, down to 3, up to 4, up to 6, 7, 5, 3, 3, 4, 4, and so on. So what the digital radio does is it takes those numbers as it's quantizing that signal over time, and it converts them into a binary format. So this is the binary format for those power levels there, or those signal levels, and that gets turned into either a low or high audio signal. And I know it looks a little bit like Morse code, but it's not Morse code, so don't make any assumptions here. Morse code does a similar kind of function. It encodes letters into kind of a digital signal, but what we're doing is we're just encoding these zeros and ones directly. So why would we want to use digital? We have the ability to do compression on the signal. There is also the ability to do encryption, but we're not allowed to use that in amateur radio, so I won't talk about that. But with compression, the audio codec is going to convert that audio signal to a digital stream. You can take that digital stream and compress it. If you guys have ever used zip to compress files, you know how you can take a 10 megabyte file and compress it down to 1 megabyte. Similar thing can happen with this audio data. Digital data can also be compressed. What compression does is it basically takes out any of the redundancies in the signal. So there's several different compression mechanisms. The particular audio codec that you're using will be the one that's responsible for doing that. And I'll also add error correction. So basically, if you guys have ever used computers back in the old days when you had a dial-up modem and you had to be able to set your modem for like 7 bits, 1 parity bit, even parity, and 1 stop bit. The even parity basically said, hey, we're going to add an extra bit and we're going to keep track of the bits that we've sent, and we're going to add those bits up. And if the bits that we've sent as part of our data came out as an even count, then we'll send an extra 0 so it stays even. And if it came out as an odd count, then we'll change our parity bit to a 1 so that it adds up to be an even number. And so that lets you detect if an error happened in your data stream. So that single bit parity is very limited on what it could detect. It could detect a 1-bit error. If you happen to have 2 bits that were in error, then parity didn't help you there. So there are actually more advanced versions of error correction. There's ECC, and there's several other different error correction modes that use multiple bits to be able to detect several bits of error and actually correct some bits of error. So depending on the audio codec that you're using, that error correction will be built into that as well. So you can also multiplex different data streams onto a single signal, right? So what you can do is have potentially multiple conversations happening on the same stream, the same data stream that's going over the radio. So that's kind of a cool thing. You can also mix your data in with your audio and carry both data and audio at the same time. So kind of a cool thing. All right, so what's DMR? DMR is Digital Mobile Radio. That's what it stands for. It's an ETSI, or European Telecommunications Standards Institute standard. This is a published standard. So anybody can build something according to this standard and it will be compatible. It's used worldwide by professional radio services. There are probably some places here in the US that use it as well. I don't think any of our stuff around here does. I think we're all on a P25 system, but I know that there are some places where DMR is actually used for commercial traffic or for civil, like fire, police, that kind of stuff. The standard defines 3 tiers or classifications of usage. Tier 1 uses a single channel, 6.25 kilohertz of bandwidth. Now, when we talk about our analog FM signal, does anybody know how much bandwidth is actually used by that signal, by an audio signal on your radio?
I thought it was 25.
That is what I believe as well. The wide FM signal is about 25 kilohertz. So this single channel for tier 1 is using 6.25 kilohertz. That's like 1/4 of what an audio or an analog FM signal would be using. The tier 1 was created specifically for unlicensed use. It's used on PMR 446 in Europe. I don't believe it's license free here in the US, although it could be. I'm not sure. I didn't dig into that very far. We don't really use tier 1 very much in the amateur area. It has a maximum of 0.5 watt power output. The band is limited to that 446 megahertz band. Doesn't use any repeaters. It's direct handset to handset only. Single channel, 6.25 kilohertz of bandwidth. It's using FDMA, which is frequency domain multi-access. Basically, that means that you have one signal on a particular frequency, and if you want a second signal, you put that on a different frequency. Sounds a lot like FRS, right? FRS or GMRS. It's very similar in its usage for that, but it is a digital mechanism. So there's also tier 2, which uses 2 channels, and TDMA. TDMA is time domain multi-access, and I'll talk about that in a minute. It uses 12.5 kilohertz of bandwidth, so it's twice as wide as the tier 1, and supports peer-to-peer and repeater operations. And this is the one that's typically used by amateur deployments. So there's 2 independent channels, each 12.5 kilohertz wide. The TDMA says basically you can run those 2 channels sequentially on the particular frequency that you're transmitting on. So they are divided up into what they call time slot 1 and time slot 2. So we'll talk a little bit more about that in a second. But each channel or time slot gets 30 milliseconds out of each 60 milliseconds of clock time. So you get time slot 1 gets 30 milliseconds, and then time slot 2 gets 30 milliseconds. So this is kind of a description of what TDMA does. So if you think about this is the signal moving forward in time, right? And it's 12.5 kilohertz wide. And so you've got 30 milliseconds for slot 1, and then 30 milliseconds for slot 2, and then 30-something milliseconds for slot 1, 30 milliseconds for slot 2, and so on. It just goes down the line that way. That window is broken down into 27.5 milliseconds of frame and a 2.5 millisecond gap. And it does that so that the radios can sync up on where they are in that stream, right? So the 27.5 milliseconds of frame can carry 264 bits of information. There's 108 bits of payload, 48 bits of sync data, and another 108 bits of payload. And then there's a 2.5 millisecond gap. Now, on the handset side, that 2.5 millisecond gap is empty. There's no transmission during that time. But on the repeater side, that is filled with what they call cache, or common announcement channel data. And that includes things like information about what the channel is carrying and what the data is going to be that's in that block. So here's a kind of a breakdown of how that timing looks. So this is be time slot 1 over here, and that's 30 milliseconds long. And there's payload, and then the sync section, and then another batch of payload, and then the gap, and then there's another 30 milliseconds that has payload, sync, and payload again, and then another gap before the next one. So this would be time slot 1, this would be time slot 2, and it just repeats over and over again. Now, on the repeater side, you've got a little bit different here. You've got, let's see if I can make this go away here. Hang on a second. There we go. So on the repeater side, oops, sorry. Turn my laser pointer back on. You've got, instead of a gap, you've got this cache data, and then the payload, the sync, the payload. Cache data fills that 2.5 millisecond gap. payload, sync data, payload, and so on, right? So again, it's time slot 1 and time slot 2. And so in 60 milliseconds, you've got 30 milliseconds of each time slot, but only 27.5 milliseconds of actual data coming through. And that becomes important in a minute. We'll talk about that later. So each channel or each time slot can carry either voice or data or a combination of the two. So because remember, it's all data by the time it hits this signal. The voice is turned into data and is merged in with that data stream. So, you know, you can carry either voice or data or both. Tier 3 is something that is not used in amateur use right now. It's only used in the professional side. It contains some extensions to the Tier 2 that add trunking and support for multiple repeaters at a single site. There are some vendor incompatibilities with that, where if your equipment is from Motorola, for example, it only works with other Motorola gear. And if your equipment is from Hytera, it only works with other Hytera gear and so on. But here's kind of an overview of how that trunking works, right? So again, it's still time slot 1 and time slot 2, but each time slot, excuse me, each time slot is either filled with a particular block of data that's on a particular trunk or channel. So you might have multiple transmitters that are carrying multiple conversations at the same time. And then you have kind of this cache layer that gives you that control that says what's what. And so your radio can identify and pick up which slots it wants to actually receive. If you're familiar with trunk systems at all, that's basically how this is working. Trunk systems are typically used by public services like your fire department or police department. I know we have a trunking system here, and there are several different radio frequencies that are in use by that. But yeah, this basically breaks that down even further into those 30 millisecond chunks and each time slot so that the payload can be transmitted out more effectively. So what does DMR give us? Why do we want it? It gives us 2 simultaneous channels. So with 1 repeater, 1 antenna, 1 duplexer, and 1 frequency, we can have 2 completely separate conversations happening at the same time. That's because the one is on time slot 1 and the other one is on time slot 2. They do not conflict with each other. So that's kind of a cool feature. If you want to run a repeater, say you wanted to run 2 repeaters, you only have to run 1 with DMR, and you can actually have essentially 2 repeaters worth of audio going around. The data goes along with voice. So if you're doing a PRS, you don't need to use a second VFO for that. It can be folded directly into the voice signal. So that's kind of a cool feature. Not every DMR radio has a PRS built into it. So, but those that do, they can fold that information directly into the data stream. The signal is clean. So you know how when you're talking on a repeater and you have somebody who's like barely making it through, they're getting lost in the steam, and you hear that kind of scratchiness or that noise in the background, you can't quite make out what they're saying. With DMR, it's digital, so they're either going to get through or they're not going to get through. So there won't be any of this kind of halfway getting through or, sorry, I can't copy you very well, can you repeat type of thing, because it's either going to be a solid, clear signal or nothing. So kind of like how the digital TV is nowadays, you either have a picture or you have nothing, right? So that's kind of a cool feature that DMR gives us, is that solid audio quality. There's also a feature called talk groups. We'll talk about that a little bit more. Talk groups are kind of like the FRS privacy tones. So if you've ever used an FRS radio and it says, oh, it's got 14 channels and 65 privacy zones, right? So privacy codes. They're not really privacy codes on FRS, but here in DMR, they actually are physically identified by a code or an ID number. And so you can have multiple conversations happening on the same channel, but they don't have to walk on top of each other. So you can set your radio up to subscribe to specific talk groups, and you'll only hear those talk groups that you're subscribed to. You can also do a private call where you can set up essentially a one-to-one talk group that would only have you and one other station talking to each other. So here's a list of talk groups that are in Utah right now. So there's local 1 and 2, which is the local repeater only, time slot 1 and 2. There's a worldwide talk group, which is on time slot 1. There's a North America talk group on time slot 1. There's a Simplex talk group on time slot 1. There's a USA talk group on time slot 1. Utah only, so Utah statewide on time slot 2. There's also a Utah group on time slot 1. The 76ers, that's kind of the guys that use the 76 repeater down on Lake Mountain. They have their own little group that gets together on that. They actually have a specific talk group specifically for the 76er group. There's also a Northern Utah group, and there's a group that's called the Echo Test. So if you get your radio out and you want to know, well, how am I sounding? You don't have to just call CQ and then hope somebody comes back and tells you how well you sound. You can actually flip to this, what they call a parrot talk group. And when you say something, it will get repeated back to you. So kind of a cool feature. It also supports repeater linking. So over IP networks, this is using a protocol called IPSC. IPSC is IP Site Connect. This is not defined by the ETSI standard, the DMR standard. So several vendors have come up with incompatible ways of doing this. And they do that because that's their vendor lock-in mechanism, right? There are systems known as a C-bridge that allow those dissimilar networks to connect together. I believe the most common one used by amateurs is called Bridge Master. I don't have any experience with that yet, but I did get my radio from UPS today, so I'll be fiddling around with that soon, and hopefully I can add some stuff to this talk for that part. With this bridging or this internet connection protocol allows talk groups to exist over a wide area. So when we talked about the talk groups, we have this worldwide talk group, North America talk group, or Utah talk group. Those can actually, worldwide, you could go on there and talk to somebody in Europe or in Australia or something like that, as long as they're on that same talk group. So kind of interesting. It also gives us a feature called zones. This is a feature of the radios. They're kind of like memory groups, but a little bit better than memory groups. So if you've ever used the Kenwood TM-D710, it has this concept of super memories where you can have like 5 different collections of programmed frequencies in it, and you can switch between them. So it's similar to that, but it's available all the time, and every every DMR radio will support this to a certain extent. They'll have some number of zones that they support, some number of channels per zone, some number of talk groups per zone, for example. You might have a zone set up for a specific area, like you might have a zone for when you're here in Utah or here in the Salt Lake Valley, and a separate zone for if you travel to another area. For example, I have family in Las Vegas. We go down there periodically. I can set up a zone on my radio for the Vegas setup and just switch directly to that zone when I get there and not have to worry about reprogramming any channels or anything.
Jan?
Yes.
Let me just add something about that. Ragnar and I, we both have mobile radios, Anytone 578 tri-band. And I created a code plug, and I'm sure you're going to get into that.
Yep, that's the next thing.
Okay. And part of that is I created a ton of zones. And one of the cool things about DMR is it's also compatible with analog radios. So as an example, I use the zone feature to group my analog channels. In my case, I have a zone that's called Intermountain Intertie. I have another zone called 1.25 frequencies And the only thing I have in that zone or a channel group is all of the 220 megahertz frequencies and repeaters that we use. I have a zone for each county in Utah. So every repeater in Utah I have in a zone that where that it corresponds. So it not only works with DMR digital channels, but it also works with analog channels. So it's kind of a cool feature.
Yeah, so that's a feature of the radio, not necessarily of DMR.
Correct.
So, but it is it's something that's part of that standard. So any radio, any DMR radio is going to support this kind of zone functionality. So let's see. The next thing I have on the list is color codes. For color codes, think of those kind of like DCS or CTCSS subaudible tones on an analog repeater. There's 16 color codes available. The repeater will only hear you if you're using the right color code. I'm pretty sure all of the DMR repeaters here in Utah just use color code 1. But if you're in an area where you may have more dense collections of DMR repeaters, you may have things running on a different color code. They would be used similarly to how the CTCSS tones, the subaudible tones, are used on analog repeaters. Code plugs is another DMR feature. It's basically a super easy way to program your rig. All you have to do is download a code plug and away you go, right? You push that code plug onto your radio and it has all of the information about it. It lets you associate your repeaters, your channels, your talk groups, and any individual radio users that you want to have a connection or have their personal information in your radio, so that if they're talking, you get a little display that shows who they are and where they're at, that kind of thing. Here in Utah, there's this DMRUtah.net, and they have a bunch of code plugs for a bunch of different kinds of radios that are already set up for the repeaters that are around here. So hopefully I will learn more about this when I am allowed to open my radio, which apparently I can't do until Father's Day. So, but yeah, they have code plugs on DMR Utah for these Motorola radios, Hytera, the Anytone or Elenco units, and the Hytera. One thing to note is that typically the programming software for DMR radios only works on Windows. Now, I don't know if it works with Wine or with any of the other solutions to run Windows apps on Linux or Mac. I will be experimenting with that to see if that's possible or not. I'm hoping that it is, but I do have a Windows machine available if I need to do it that way. So that will be something that I experiment with, and hopefully can add some more to this presentation about that.
And let me also add, if I could, Jan, with the code plugs, that's where I started. I used a code plug that I got from DMR Utah, and I built on top of that. So you can, I mean, people write code plugs all over the U.S., all over the world for that matter. And Utah is nice because it has all the DMR repeaters and whatnot. So it's good to utilize that. But you take a code plug that's already written and you use that kind of as a starting point to build your own code plug, because you can, using the programming software, you can create your own code plug. And once the code plug is created, which is really a code plug is nothing more than a group of files that make up, there's a separate file for by the way, the files are all CSV type of files. You have a file for talk groups, you have a file for zones, you have a file for digital channels, you have a file for the contacts, the 200,000 possible contacts. Anyway, there's at least a dozen of these files, and they are all grouped together, and that conglomeration of files is the code plug. And so when you can distribute that to other people that have DMR radios, and they then load it onto their radio, and then they'll have the same file structure, i.e. the same data that you put into the file structure as what you created. You don't work at it as files. When you work on it, it is a GUI system, and once you save all of this stuff, you don't realize how many files are being created. All that's done in the background. So it's quite interesting, the number of things you can do with those code plugs. I'll shut up now.
Thanks, Dan. I wonder if you could send me a copy of your code plug that I could take a look at, because
Sure.
I definitely will want to do some experimentation with that.
Yep.
And it's always good to start with something that works. So
yep.
That would be great. So what else does DMR give us? DMR gives us scanning capability. Obviously, we can do scanning on an analog radio, but DMR radios also support that. You can also set your DMR radio to what they call promiscuous mode, where it will actually listen to everything that's coming across the repeater and kick it all out without paying attention to what talk group it's on, or if there's anything that's happening on that channel, it will go ahead and just play the audio for that for you. So you can actually listen to both time slots. You can listen to multiple talk groups at the same time and that kind of thing. So kind of a different feature, but it's something that DMR has the ability to do. Plus the DMR radios can also do regular analog scanning as well, just like you would on a regular radio. There's also a roaming functionality. Not every DMR radio has this capability, but the idea is if you've got multiple repeaters in an area that are running the same set of talk groups or running on the same bridged network, that your radio can determine which repeater it's closest to and automatically switch from one to the next as you move around. So that's something that's more important for mobile users. If you're a home user, or if you're not moving around very much, it's not so valuable. But if you're a mobile user, you might find that roaming functionality is actually pretty cool. It hands you off from one repeater to the next as you move around. So that's a feature that DMR has. There's also a simplex functionality, which is basically handset to handset without a repeater. That's the tier 1 that we talked about earlier. And so that capability exists. There's a capability called admit criteria, which is basically when you key up your radio and you say something, the radio is not necessarily going to transmit it right away. It's going to ask the repeater if it can talk. And so it's going to send over like the color code that it wants, and your digital ID and that kind of information. And then the repeater will actually send back a signal that says, okay, you can send your data to me now. And then the signal will go through to the repeater and then go off to wherever it goes from there. But that's kind of a different way of thinking about that. You don't have to worry about walking on another transmission, or doubling, as we call it. I know when we did our 220 check-in towards the end of it there, Bob was trying to check in and Dan was talking at the time, and I could hear Dan talking, and I could also hear some noise coming from Bob, and I could tell who it was because I know what Bob's voice sounds like. But obviously Dan couldn't hear him because he was transmitting. So the DMR radio will prevent that from happening. So you won't run into any situations where you're doubling on a DMR type of setup. Also, the DMR radio's battery life is typically much better because the transmitter is only on 27.5 milliseconds out of every 60 milliseconds. So it's only actually using transmit power a little less than half the time that you're transmitting. So that's kind of a cool little feature. A lot of these DMR radios have pretty beefy batteries on them too, because they were designed for commercial environments where the guy's going to have their radio on for 12 hours. So the Anytone radio that I bought has, I think, a 3100 milliamp hour battery, and I fully expect that to last all day easily. In fact, a presentation I was watching on it showed that if you were just listening it could last up to 3 days on a single charge. So, that's a lot better than I would get out of my analog radios. So what do I need to play? You need to get a radio. You can either pick up a commercial radio, you can pick up a used commercial radio, or you can buy one. I don't recommend necessarily doing that because now there are non-commercial radios available that are much cheaper than those commercial radios. And for amateur use, I can't see spending $800 to $1,000 on a handheld when I can buy one for a couple $100. Non-commercial radios, there are several different manufacturers: TYT, Baofeng, Anytone. I have a couple of links on here. I will say that I misspelled Baofeng, and I will say that these are Amazon affiliate links. So if you do click on that link and end up buying a radio, I will get a little bit of a kickback on that. It does not make your price any higher, but it does give me like, I think it's like 0.1% or something like that. So just be advised, if you don't want to buy through Amazon, certainly you don't have to. I also put a link here. It's a bit.ly link to a YouTube playlist, the Ham Radio 2.0 YouTube channel, I guess you'd call it. He has a nice playlist set up where he reviews a whole bunch of different DMR radios. And so you can actually run through. He's probably got about, at least 5 or 6 hours of content where he's reviewing all these different radios. So you can take a look at that playlist and see what's there. The next thing you need to do is get a digital ID. You only need one. No matter how many radios you have, you can use the same digital ID for all of your radios. But you go to this radioid.net/register. They actually do require that you upload a copy of your FCC license if you're here in the US. So the FCC, if you go on the ULS system, you can actually download a copy of your license and then upload that PDF file to radioid.net. They just need to verify that you're actually an amateur radio operator.
And I will add, if I could, Jan, you only need one, like you said, but they allow you to use two. And I have 2 digital IDs, one for my mobile radio and one for my handheld radio.
So the only reason you would want that is if you were trying to use both of those radios at the same time, right?
Yeah,
so
correct.
Which I guess you could do if you wanted to set up some kind of like a, what do they call that when you're doing a crossband repeat or something like that? That would be about the only time I think you would want to use 2 radios at the same time.
Mm-hmm.
I don't know, Dan, can you think of any other cases where you would need to do that?
Yeah, I can lend someone who doesn't have a DMR radio.
Well, there you go.
And I can be on my mobile, and I can be talking to that person. And when he transmits, he'll be, and this is...
So he'll be identifying as you, though.
He'll be identifying as me, yeah. So actually, I'm not sure the legality of that.
Yeah,
that's interesting. I have to think about that. Yeah.
Then you need to get a code plug. So around here, you go to DMR Utah. There's a link to it right here on the presentation. And you can download a code plug for the radio that you have. Or there's code plugs, like Dan said, all over the internet. If you Google for a code plug for your particular radio, I'm sure you can come up with one. And then you can put in the appropriate frequencies for the DMR repeaters around Utah. This DMR Utah, they actually have a nice site where they talk about the things that are the repeaters that are using DMR here in Utah, what the code groups or what the talk groups are, and all of that information. So you can definitely take advantage of that. Another thing you might want to pick up is a digital hotspot. What this is basically a little tiny radio that hooks up to the internet. You put this at your location, you run it on simplex. It's very low power, and it basically gives you access to a particular digital radio setup. And most of these will actually support multiple digital formats. So like you can see, this will support D-Star and DMR and NXDN, whatever that one is. There are several different things that they'll support. I'm probably going to pick one of these up, as I said before, on my next gift from my wife. So you typically have a Raspberry Pi CPU in there and a transceiver daughter board, and you can get them in a little package. I found one on Amazon for $106 that can certainly do the job, do everything that you need it to do. This would be useful for you if you're in an area where you don't have any DMR repeaters around. I've heard of some people putting these actually in their car and tying them to a GSM modem so that they're running the internet side of that over the cell phone network, and they're able to do their DMR mobile in that fashion. So kind of a different way of doing things. But
also, I might add, it also extends the battery life of your HT, because now you can go to very low power, and if you're just talking to your hotspot in your house, you can go for weeks on your HT. So very cool.
Yeah. So that's all I have. So we came in about 30 minutes, 35 minutes for the presentation.
Yep.
I have a list of references here. I'm happy for anyone to check those out. Any questions that I can answer for anyone, please feel free to bombard me at this time.
I just have a comment.
Go ahead.
I don't sleep that well in the middle of the night, so I enjoy talking to Europe at 3 in the morning, and it's later in the morning over there. So there's a lot of contacts you can make in the middle of the night here, where everyone locally is asleep, and you can talk all over the world. I think I've thoroughly enjoyed that.
So definitely take advantage of that worldwide talk group. And there are also country-specific talk groups that you can select. And if you want to talk to someone in a particular country, for example, Norway, there's a particular talk group just for Norway, and you could connect to that and talk on that talk group and make contacts with people in Norway. Ragnar, I assume people on that would be speaking in Norwegian, so that would be something you could handle, but the rest of us maybe not so much. But
actually, the talk group I use is 4040, and most people in Norway like to try their English out.
They like to practice their English.
Correct.
That's good. So I think you will find that a lot of people worldwide do learn English. It's something that we Americans, we are kind of language centric, and we tend to think, well, everyone should speak English because that's what we speak. And because the U.S. is such a powerhouse on economy and all of that, that actually has become the case where people in other countries choose to learn English specifically so they can talk to people in the U.S. So kind of an interesting
and
factor.
if they want to do business in the U.S., they'll want to learn English.
Right. Just like if go ahead.
I was just going to ask Dan on that 578. Does that have APRS too with that?
Affirmative.
Have you used that? Was that what you were using when we were doing the APRS, playing around with that?
No, I was using my FT2DR Yaesu radio.
Okay.
But it does do APRS. I haven't figured out how to do it yet, but I haven't actually put a whole lot of effort in that. So I do need to figure that out.
Well, that is something that I want to try as well with my radio. So if I figure something out, I will add it to this presentation.
Hey, I might add another source for radios, and I don't want to take away from your Amazon account.
Oh no, please do take away from it if you feel obligated to do so. I only put those in because my browser automatically adds those. automatically adds my affiliate tag.
Yeah.
But I definitely disclose that that I'm doing that. So, you know, I don't want people to think, well, Jan only wants us to buy through Amazon because he wants money. So
Yeah,
you know.
no. But my only point is, Bridgecom, when you buy a radio, especially a DMR radio, they give you what's called Bridgecom University, and it is 24 videos taking you down through each what's a code plug, how do you do a code plug, how do you install a code plug, you know, how do you modify the code plug, how do you create a code plug, etc., etc., etc. And it's a good resource that they give you for free when you buy a radio there. So another radio that you may put on the list is the Anytone 578, which is that tri-band DMR radio. And it's, you know, I'm still going through Bridgecom University because there's a lot of videos on DMR. It is not the simplest thing to get right into, and so I'm glad that YouTube is full of you know, places to learn. This presentation was excellent, and it, you know, you were dead on. So it was, but this is the type of stuff that they have at Bridgecom University. So just another option to look at.
I'm going to stop sharing at this point and go back to my video, and I'm going to stop recording.